Today we're going to talk about the law of sines. By the end of this video, you should be able to use the law of sines to solve any triangle, and you should be able to understand the three possibilities of the ambiguous case. The law of sines can be used to solve any triangle. This means that even if you don't have a right triangle, you can still solve the triangle using law of sines. If A, B, and C are three sides of a triangle, opposite angles A, B, and C respectively, then the law of sines says that A over sine of angle A equals B over sine of angle B equals C over sine of angle C. Let's look at our first example. We have, if the measure of angle C is 29 degrees, the measure of angle B is 62 degrees, and A is 11.5, then solve the triangle. So let's fill in the information that we know. We are told that angle C is 29 degrees, angle B is 62 degrees, and we know that A, the side opposite angle A, is 11.5. I'm going to label this side B and this side C. The sides are labeled according to the angle that they are opposite. First, let's find the measure of angle A. You should remember from geometry that the angles of a triangle always add up to 180 degrees. So we know that the measure of angle A is going to be equal to 180 minus 29 minus 62. So the measure of angle A is equal to 89 degrees. Now we need to find sides B and C. I'm going to go ahead and find side B first. So I'm going to use the law of sines. I know angle A now and side A. So I need to use that as one of my proportions, and since I'm trying to solve for side B, I'm going to use B as my other fraction in the proportion. So I have that 11.5, which is the side length, over the sine of 89 degrees is equal to side B over sine of angle B, which is 62 degrees. And we just need to solve this for B. Remember, since we're trying to avoid round-off error, we will not round anything until our final answer. So to solve this, I need to multiply both sides by sine of 62 degrees, which will give me that B is equal to 11.5 times the sine of 62 degrees over the sine of 89 degrees. Now I can put this in my calculator. When I type this in the calculator, I get that B is equal to 10.155, rounded to 3 decimal places. Now I need to find side C, and I'm going to use the same method. I suggest always using the information that you are given in the problem instead of pieces of information that you have calculated to avoid additional round-off error. So to find side C, I'm again going to use the proportion for side A equals side C divided by sine of angle C, which is 29 degrees. To solve this, I'm going to use the same steps that I did to find side B and multiply by sine of 29 degrees. So when I plug this in my calculator, I get that side C is equal to 5.576 units. And now we have solved this triangle. The one issue with the law of sines is that sometimes it's impossible to form a triangle based on the information you're given. Sometimes you can end up with two triangles. That is called the ambiguous case. So if you are given an angle, its opposite side, and one of the adjacent sides, you have to be very careful. So this would be a situation where you are given this angle, its opposite side, and then one of the other two sides. The reason that this is a problem is because supplementary angles have the same sine value. Those of you who are already familiar with the unit circle should be able to see why this is true. Those of you who are not familiar with the unit circle yet, we will get to that in our next unit. Remember that supplementary means that two angles add up to 180 degrees. So let's look at the three possible scenarios. Here, we are told that the measure of angle A is 52 degrees, side A, which is opposite angle A, is 800, and side B, which is opposite angle B, is 775. We need to try to solve this triangle. As you can see, we are given an angle, its opposite side, and one of the other sides. So we're going to have to double check our work at the end. I'm going to label this side C. And I'm first going to solve for angle B. I know angle A and its opposite side, so I'm going to use that to write my proportion. I'm going to have this equal to side B over sine of angle B. When I start solving this, I'm going to end up with sine of angle B equals 775 sine of 52 degrees over 800. And then I need to do the inverse sine of both sides. So I have that B will be the inverse sine of this fraction. If I plug this in my calculator, I get that the measure of angle B is 49.764 degrees. Now, let's proceed and finish this problem as if this is the only possibility for the measure of angle B, and then we'll come back and check the second scenario. So if the measure of angle B is 49.764, then we can find the measure of angle C by subtracting the two angles from 180 degrees. And we get that the measure of angle C is 78.236 degrees. If this is the case, then we can find side C. I'm going to use the law of sines, starting with side A over the sine of angle A equals side C over the sine of angle C. And if we solve this like we did on previous problems, we get that C is 800 times the sine 78.236 degrees over the sine of 52 degrees. Plug that in your calculator, and you get 993.892. Now, let's check and see if there is a second possible triangle. We know that the supplementary angle to angle B will have the same sine value as angle B. So that means we have 180 minus 49.764. We get 130.236 degrees. So this possible second case would have angle B be 130 some degrees. To see if this is a possibility based on a triangle, we need to look at what angle C would have to be. Well, the measure of angle C would be 180 minus 130.236 minus 52, which is going to give us a negative value. You cannot have a negative angle when we're talking about triangles, so this second triangle does not exist. There is only one triangle in this situation. Let's look at the next problem. In this problem, we're told that the measure of angle B is 52 degrees, side B is 550 degrees, and side C is 775 degrees. So let's go ahead and start solving. Since I know side B and the measure of angle B, I'm going to start there. I'm going to try to find the measure of angle C. I know that side C is 775. If I start solving this, I get that sine of angle C equals 775 times the sine of 52 degrees over 550. Now, just to show you something, I'm going to evaluate this right here. So I have that sine of C equals 1.110. Now, those of you who have already learned about the unit circle know that sine can never be greater than 1 or less than -1. So, since we have a number that is larger than 1, there is no angle with this sine value. So, this cannot form a triangle. If you went ahead and typed C equals the inverse sine of this fraction in your calculator, you would get an error because there is no angle with that sine value. This is the type of situation where we know that there is no triangle. Our last possible scenario tells us that the measure of angle C is 52 degrees, side C is 650, and side A is 775. Since we know angle C and side C, let's start there. 650 over sine of 52 equals, and I'm going to try to find the measure of angle A. 775 over sine of A. So let's start solving for A. I get that sine of A equals 775 sine of 52 degrees over 650. So A is the inverse sine of this fraction. If I type this in the calculator, I get that the measure of angle A is 69.976 degrees. Now that I know the measure of angle A, I can find the measure of angle B. This is 180 minus angle C minus angle A. So the measure of angle B is 58.024 degrees. Now I can find side B, which is this side. I'm going to start again with my fraction for side C and angle C, since that's what I was given originally, to avoid round-off error, equals side B, which I don't know yet, over sine of angle B. So B equals 650 sine 58.024 over sine of 52 degrees. If you plug that in your calculator, you get that side B 699.706. Now, let's go ahead and see if there was a second possible triangle. We need to go back to angle A. So the second possibility is if the measure of angle A was 180 minus what we had in the red box above, 69.976. This gives us that the measure of angle A is 110.024 degrees. If this is the case, then the measure of angle B would be 180 minus 52 minus our new angle A, which gives us an angle B of 17.976 degrees. This time, when we tried to find the second triangle, we got a positive angle for our third angle, which means there is a second possible triangle. So let's continue. We have a second possible angle A and a second possible angle B. We now need to find the second possible side B. So let's go back to the law of sines. We were originally told side C and angle C. We're trying to find our new side B given our new angle B. So if we solve this, we get 650 sine of angle B over sine of 52. And if you plug this in your calculator, you get 254.568. So we have two possible triangles here. The given information stays the same. The first possible triangle has these possible measurements for angle A, angle B, and side B. The second possible triangle has these measurements for angle A and B and side B. Remember that this situation where you have to check for a second triangle only happens if you are given an angle, its opposite side, and one of the adjacent sides. If, like the first example, you are given two angles and a side, you do not have this ambiguity.